Okay, I think we can go ahead and get started. Welcome everyone to this webinar on SolidCAM Thread Whirling. This webinar will be presented by Stanislav Duba. He is SolidCAM product manager from the Czech Republic. We will try and have question and answers at the end of this webinar if time permits. If you have any questions, please type them in and we'll try and answer them at the end. Thank you very much. And Stanislav, you can go ahead and start.
Okay, thank you very much. Hello everybody, thank you for joining SolidCAM webinar series. Today I would like to talk about thread whirling. It's a relatively new technology, a very effective technology that allows the machining of very high quality threads without risk of bending or vibrations. In today's webinar, I will show a little of the history of the theory, how does it work on the machine, how to set tool and everything, how to enable thread whirling job inside the settings of SolidCAM. We will check together two different parts. One will be simple screw with constant thread, and second will be also screw but with a customized profile. Then I will speak a little bit about the toolkit, how to set correctly tool, lead angle, and we will try to define our own tool from a manufacturer catalog. We will see job settings and all options what we have. Okay, so let's start. So like I said, thread whirling is effective technology, threading technology that allows the machining of very high quality threads without the risk of bending or vibrations. This technology in the combination with Swiss type machine is very suitable for very long parts and also for the parts with high length to diameter ratio. Typical parts where the thread whirling technology is used for the machining are bone screws, implants, feed screws, worm gears and other micro components. On the right side we can see typical bone screws, which is very typical for us, and here is the thread tool. The thread tool, the thread whirling tool, it's where all the magic is happening. The magic is happening because multiple inserts are mounting in the inside of the whirling ring, which is in this middle. This ring rotates inside a special tool holder, which is usually consists of two main parts, which we call head base and rotary base. On the right side, you can see the head base, which is mounted to the machine, and rotary base, which is mounted to the head base. Rotary base holds the whirling ring and it's mounted to the head base with adjustable angle, or what we call lead angle. Okay, this can rotate around its own axis. The main principle is that during the machining, the part is rotated using a spindle axis, C axis, and the whirling ring rotates with the given spin value. So as we can see on this picture here, we have a very nice thread screw again, which is rotated by C-axis, and also we can have here the thread whirling head, which is adjusted by lead angle, and also with a given tool spin, it actually machines adjusted thread. So let's take a look. How does it look like in SolidCAM? Before we start itself, we have to be sure that thread whirling is open on your machine, on your computer. So let's jump inside CAM settings, inside miscellaneous, in the beta options, and here we have thread whirling. So please make sure if you want to use this option, you have to have this one enabled. So let's go and let's start and open the first part. Okay, like I said, here we have very nice bone screw. It's very typical part for thread whirling. And what I like to do before actually we start thread whirling operations, I like to prepare my part, to examine it a little bit. Why? In most of the cases, you will have this part with drawing. You will know the minor diameter, minor diameter, and your pitch. If you don't have drawings, you need to examine them, because this operation, what I will show you, needs all of those values. So what I like to do is use section view and a little bit examine it here. So we need three things to know. We need to know a minor diameter, which is from the lowest point of the thread to the center. It's 0.95. It's radius times 2, its diameter. So if I count it correctly, it's 1.9. And we also need to know the major diameter. So it's 2 millimeters, again radius, so my diameter will be 4 millimeters. So it's about diameters, and now I need to know the pitch. Pitch is the distance between two passes of the thread, so I can choose, for example, from this place to this place. All right, 1.75. Okay, so I have examined my part. I also already prepared my part a little bit, so I get rid of the all material which is not necessary for us, and we can go straight to thread whirling job. Thread whirling job can be found under milling operation, and directly under thread milling is thread whirling. Okay, so what we can see here, coordinate system, we are using our Mach 1 position 1, and here we can see thread profile. When the thread profile is not selected, the toolpath will be calculated for the thread with the constant diameter. This is our case. We have constant diameter, so we will not use it thread profile for this case. I will show you on the second part. So let's jump directly in the tool. So let's go to the desired station, and here you can see that we already have one prepared tool. It's a completely new tool type. It's located under special tools group, and it's called obviously thread whirling. So let's simply drag and drop here, and as I said, it consists of head base, rotary head, cutter, and all inserts. The newly created tool has all predefined holder structure with default STLs models. So you will get it always when you have correct install of SolidCAM. The created holder has predefined component called predefined component axis called lead or lead angle. Okay, where we can adjust the angle of the rotary base part and to the holder base. So if I will, for example, rotate like this one, we can see that it rotates very nicely around the x-axis. Like I told you that we have three things which we need to know for the machine of the thread. It's major diameter, minor diameter, and pitch. If I go inside my cutter, I can start to fill up. So my pitch was 1.75. My cutting diameter is now currently 12 millimeters. It's this one. We measured that my biggest diameter is 4, so I am pretty much inside, and I don't need to do anything with that. I have number of the teeth, I have 6. Thread cutting is 0.5, so let's make it a little bit more to be sure that we will not cut anything with our holder. And the most important thing here is the lead angle. Lead angle actually defines how will be the thread. If you know your lead angle directly from the drawings, you can simply go inside and put some value. If you don't know, we created for you lead angle calculator. Lead angle calculator is it's very simple, all right? What we need is minimal diameter, maximum diameter, pitch, and number of threads. So we said that our minimum diameter was from this one to this one, so it was 1.9. My maximum diameter but it's cutting diameter. So now we need to be careful. It's not this one. We have constant diameter. We do not change the diameter of the thread during the machining. So it will be also 1.9. Pitch is 1.75. Number of the threads, I will have only one pass. And I will hit the calculate button. Because we have a constant thread, we have 3 different results: average, max angle, and min angle. But in this case, we have all of them same because it's constant. So it doesn't matter what do you choose, it will be always this angle. So I will choose, for example, average, and we can see in the preview that it's rotated by 16 degrees. So let's go. In the levels, I have to define my upper level, like you can see on this nice picture. So we start in the 0, and my thread depth will be over here. You can define by the value or by number of the threads, but I would like to define by the value. So inside the technology, we have to set the thread data. We have to set a major diameter. It was 4. It was from the highest point to the center, or I mean the diameter, and we have to set minor diameter. It was 1.9. Our pitch is 1.75. You can also use thread per inch. We have direction, the right hand or left hand. If you are not sure in which direction is your thread, it's always easy to just imagine that you have here the nut and you are trying to rotate on this thread. So if you're going to the right side, it's right hand. If you go to the left, it's left hand. So obviously this one, if I will try to rotate to the right hand, it doesn't work, so it's left hand. We have options to cut from bottom to top or top to bottom. I would like to from top to bottom. It's oriented according to the Mac. And currently, let's do it on the one finish pass. Okay, we have first toolpath. Very nice toolpath. Let's check it on the machine preview. How does it look like for better orientation? I'm on the Swiss type machine. It's very, very crowded here, so we have to be a little bit more focused on the preview. All right. So my lead angle is rotated clockwise to 16 degrees. I see that also my thread has this orientation, so I'm pretty sure that when I will put it on the machine, it will cut it the right thread. If you check it by your machine preview, and you will see that your thread is on the opposite side, it's very easy to go back to the toolkit and change your lead angle to the opposite side. For you who wonders why we actually go from this place to the center and then back from the center, I will show you now the simulation. Okay, let me hide a little bit of this part of the machine for a better view. Hide it, and I will make it like this one. And hide toolpath as well, or maybe we can leave it here. So we move to the center because our cutting point is in the center of the rotation. And from the center of the rotation, we need to do, let's say, movement, down movement. But actually on the thread it will be the tooltip of this rotary insert. All right. So that's the reason why we actually start from the center. And this is actually the whole cut, how it's done on the machine. Okay, we can see maybe even from the other side. Yeah, we can cut very nicely. Okay, that was for the simulation. What we have or all options. Currently profile geometry is suppressed. Modify geometry is not possible because we didn't select any profile of the job, so we will show it on the second part. We can enable the rough. We can do rough by single pass or multiple pass. If I do single pass, I need everything what I need to do is put some finish allowance. So for example 0.2 for the finish pass, and now I will have two passes, one for the rough, one for the finish. Okay, or we can have multiple passes. We can say that first step over will be 0.1, for example, minimal step over 0.1, and allowance again 0.2. So now he will calculate the number of the steps to put it directly between major and minor diameter. Okay, so now we have very nice several rough toolpaths and then one finish. Okay, let's put it back to single. What is also very important to say is we have here advanced tab. In advanced tab, we can say that we have options for the number of the starts. So if you take a look from the top of the part, we have only one start and go for the rough and for the finish. But I can have a lead, for example, with thread with two leads. Okay, so we will have first one, and here we'll have the second one, which is very nice. So we can have a thread with two leads. What is also very necessary to say that we have new options split toolpath along z-axis. This feature was added to this advanced technology. This feature is used when we need to perform multiple passes and enable us to split the whole thread into shorter segments. It's absolutely crucial on Swiss type machines when you cannot return your part inside guide bush, and during the operation all cutting passes are performed on the one segment before the tool moves to the next one. So I can say that my distance will be for 3 millimeters and overlap, for example, 0.2. So my toolpath will be splitted after each 3 millimeters, and here we can see. So we will do the first 3 millimeters, and then another 3, another 3, another 3. In that, also we have possibility to do sorting. Sorting means that we have two options: complete step over and complete thread. For complete step over, I will finish everything in an area of 3 millimeters. It means that I will do rough in 3 millimeters, finish in 3 millimeters for the first lead, and then again rough and finish for the second lead, because we have two starts. And then I will move to the another segment, which is from, let's say, from -3 to -6, and so on and so on. So we can do complete step over or complete thread, up to your capabilities and your machine. Okay, very nice. It's very crazy. So let's put it back to one, for example. You see that when we have only one pass, the sorting is disabled automatically. In the link we have, like you always know from the milling, we have lead in by arc or normal. We can do the same over here. Okay, for example, by arc. Arc was before, now it's normal. And on the motion control, there is one thing which is mentioned to be noticed. When we do actually cutting, the cutter always has the tooltip as the center, but we always cut with the top of the head, all right, with this part, with this side. For some technological reasons, if I need to switch to the other side of the cutter over here, I have possibility by 4-axis indexial rotation angle. So I will rotate by 180 degrees and it will switch from this place to other side. So let's try to calculate and see in the simulation if we will be on the other side of our part. Okay, and let's go step by step. So in the center, and from the center now we should go slowly to the right side of the cutter. Exactly. So this is 0 for us, 180 degrees. So it's like x plus, x minus, y plus, y minus. It depends also on the technology side and also on other stuff. But we have the possibility to select which tooltip will be used for real cutting. And as you can see now, we are cutting from 0 to 3 millimeters, and then returns, it's always rough, finish, and then switch to another segment, and so on. So yeah, very nice movement. Okay, I think we don't need to simulate all the thread. What I would like to show a little bit more is also, let's put it back to 0 to be in X positive. And let's try to generate our G-code to see how does the G-code actually look like, and try to put it also in the backport, the Simco. So as you can see here, we have very simple G-code. We are going to the center of the part with some safety of 25. We are going slowly down, and here we have G3, which is a new procedure spiral, which is actually the cutting of the thread with H command. This H command is the length of the spiral, and the purpose of this H is to significantly reduce the size of the program and make it easier for the operator or to make some eventual changes. So here we can see our nice toolpath. Maybe you can notice that there are some arcs inside, but it's because of the Simco. The new Simco is kinematic, so it takes also the movement of the rotary table. Okay, very nice toolpath. Short, simple, very nice. Okay, so I will close this one, and I think now it's the time to switch to the second part with the custom profile. Okay, so it's very nice part as well. This one is also used in medical stuff. It's also for the bones. And on the right side, we have a constant thread, which is not interested for us right now. We will be focusing on this left one, which as you can see, it's not on the cylinder, it's like a cone. So we will try to make this one exactly how it is on the shape of it. Now I think the good point is to show that we should use also, we have the possibility to import inserts, also holders from the manufacturer catalog, and we can use exact shape of the thread on the shape of insert. So the easiest way is always, go on the website of the manufacturer, for example of the Star, and you can download whatever holder do you need. Okay, for example this one. You can see that here we have step file, so it's something like this one, and it has all the components. So we can download it as the step file and try to open in SolidWorks. So I will open it. This one. Here I would like to say only one thing. I already opened it before, and I have to a little bit reduce it because this was very detailed. It has more than 250 components, especially inside, because here it was shoved with the gears, with the bearings, with the boards, with everything, and it unnecessarily slowed the SolidCAM. So if you will download such a tool, please try to reduce the number of the components inside. So we have the holder, but as you can see, we have no inserts. So I will also put here my new component. The new component is my thread whirling insert. I designed this one by myself. I took it directly this shape from the shape of the thread, what you saw before. And now just very quickly, let's build this tool. So let's do some mates. Let's do it on opposite. Yes. This face with this face. Yes. This face with this face. Yes. Okay, so we have our insert on the place. We will make some axis. We will make some circular component pattern. So because we want to have more of those. Select this axis and component the pattern. This one, I want six of them. Yeah, okay. So our tool is pretty much ready. Before importing the toolkit, we need to do one more thing. We need to set two coordinate sets. One coordinate set will be for cutting point, which will be on the top of the insert and in the center of the rotation. So I will draw here I will draw here a circle by 3 points. Let's say 1, 2, 3, and some lines for our x and y axis for the coordinate system. So go inside reference technology coordinate system. So I will select this center, this one, and Z has to go inside. So XY will be like this one. Perfect. I will just rename it as cutting point. So this is our first coordinate system. This will be for cutting point. Second coordinate system needs to be for mounting this whole tool assembly in the station. And it will be on this top of the plane, on top of the surface, and in the center of this circle. So let's see again. So we will make some construction lines. Okay, something like this one. I will take my coordinate system, center and y-axis again like this one. Why like this one? Because I know that on my machine the x is for the station, and rename it as station coordinate system. Nice. Okay, so now we are ready and we can go and import inside toolkit. So we go inside SolidCAM, toolkit, new tool library, and new tool assemblies. Here we have, like you saw, I guess, several times in previous webinars, we have options import tool assemblies from CAD. And as I said, it's milling operation, so we have to generate it as milling tool. All right. So we see here several components, and we need to do some adjustments. All of those insert has to be unite the cutter. Okay, now see that it's very nice and yellow. All of those has to be holder. It was shrunk. So again, holder. My mistake. And we have to say that we will use our coordinate system which we prepared before. So for whole component here will be change reference coordinate system to station coordinate system. And the second one will be for the cutting point. But before we do that, take a look. Here we have end mill. I don't want end mill, I want my special cutter, thread whirling. And I will use change reference coordinate system to cutting point. Okay, here we are. The last thing what I would like to prepare is inside in the real life is a shaft which actually rotates through the machine to this whirling ring. So there is some real gear. So we will put it here as well. So set connections to drive unit as a gear. Okay, let's see. So import to our storage. Oh, here we are. I love the new toolkit. And the last thing what we need to do, well, here, like you see, there we don't have the lead angle axis component. So we need to go on the holder in the connections, and we will add a new joint. It will be rotary axis. This axis will be called lead angle, and it will be around, take a look, x-axis. So we will use x-axis here. Okay. And we need this child component use joint tool, which we just created. Okay, so take a look. Here we are. It's ready to rotate. Okay, so we will save it as our thread whirling webinar. Save and leave it here. Okay, I can close this one. Yes, why not? Save it all. So before we open the job over here, I would like to jump back to my presentation and show a little bit more. So we prepared our tool. And now we need to prepare a little bit our part. Why we need to do it? In order to have correct simulation and all data, we should use customized thread insert, what I just created, as you can see here, with the shape of insert exact as shape of thread. And the main idea behind the thread with a customized profile is to have some, let's call it construction line, which is drawn from, which connects from the lowest point of the thread, the highest point. And as you remember, we created some cutting point. This cutting point is created on the front surface of this insert and on the bottom of this one. In the other words, on the virtual corner. This cutting point has to follow the construction lines, but if it will follow a construction line exactly how it is now, it will definitely undercut the part. So what I will do, I will offset my construction line exactly for the distance of the cutting point to the tooltip. Okay, so let's go back inside SolidCAM and do the same again. I will use section view. Let's use this one, and I will create some helping line for top and on the plane. Okay, let's rotate it back. Sorry. Yeah, something like this one. So like we said, we need to connect the upper part of the thread with the lower one. This is our construction line or profile line, which we will use later in the job. Okay, but I know, let's go a little bit. So I know that I need to shift from the cutting point to the tooltip. How I can know this distance? Very easy. Let's open our thread whirling insert and let's measure it. So let's go inside, evaluate, measure. So it's from this top face to this corner. And we can see that it's 1.314. Okay. So I will do offset. This offset will be exactly offset from the tooltip 1.314. And from this point we need to do sketch, or yes, we need to do sketch, which will actually be parallel with this construction line. and it will be our final. So this one will be parallel with this one. This one will go through our offset, so coincident. This one will be coincident with this one, okay? And I will extend it a little bit more to the other side as well. And on the other side, it's same story. So from the last part to this one, we will use 1.314. Okay, so this is our thread profile line, which cutting point will be followed. Okay, save it and try to go inside. So again, milling operations, thread whirling, and this time we will enable thread profile. When the thread profile is enabled, this option is to define the geometry in the XZ plane to support thread with with the custom profile. So let's select the new one. I will disable this one for sure. Okay, let's take this one. Okay, let's select our newly created tool. Let's jump in designated station, and this time I will not take this predefined by the SolidCAM, but I will take from tool assemblies which we created a few minutes ago, and it was Thread Whirling webinar. Okay, it's over here. Nice. So import. Very nice. It's over here. I will just break a link here because I need a little bit fill up all of our tool properties. And tool properties, we didn't measure the pitch and the rest of the things, so let's try to measure it. So I will measure my pitch. The pitch is the easiest here, so I will take it from this place to this place. It's exactly 1 millimeter. Very nice. Cutting diameter is 12, can be 6 inserts. Thread cutting, for example, 20 again. And now we will jump inside tool lead angle calculator. We said that we want to have minimum diameter. What is the minimum diameter on our thread? It's exactly this one to the center. So it's 1.1 radius, so diameter will be 2.2. My maximum diameter is on the other side, and it won't be this one. It will be this one, on which will be the cutting point. Okay, so it's 1.84. Let's measure, let's calculate 1.84 times 2, 3.68. 3.68. Okay, thread pitch we measured, it's 1 millimeter. Threads will be only 1, and let's calculate. Now we have 3 different results. It depends how much steep will be the angle for our thread. I will choose currently our maximum angle, what will be around 8.2 degrees. I will say OK, and our tool defined from catalog is now set it correctly and with correct lead angle. So let's hit OK. Levels. Now notice that currently all levels are disabled because all levels are followed by a line, by the sketch which we created. Okay, so you are not able to change it. Inside technology, on the other hand, we open modify geometry. So now you have possibility to extend our start or end of our profile if you want to. You can also modify offset, up to you. What is here? It's new. It's thread height. In other words, it's the height of the material for rough offset. So I know that I measured it before. It's 0.2. It's like the distance from the minimum to maximum. And the rest of it, like before, we have our pitch. It's 1 millimeter. Right hand or left hand. If I will take a look again from this side and I will try to rotate, all right, so it's right hand, and I want to go again from the top to bottom, so from top to bottom, okay, because it's oriented according to the Mac. And let's try to finish, let's try to leave it only again on one finish pass. Nice, we have very nice tool path. Great. As you can see, the tool path is gradual, so it's slowly going down because we need to go on the part, you know, like we are going upper and upper on our part, we need to go lower and lower with the tool. I know that it can be a little bit confusing, but after a few rounds, you will be very used to it. So let's try to see how does it look like in our simulation. Okay, here we are. I will hide again this part of the machine which we cannot see anything over here. And let's do workpiece and try to run. Alright, so we can see that it starts to cut. And we do, actually now it's only done by one finish pass. I don't want to do more passes for now, but I believe it will be fine even with the rough and even with the multiple or single pass. Maybe let's remove the stock to be a little bit faster. Maybe a little bit, put it to the faster side, yeah. See, this is another reason why we should reduce the STL holder, the number of the components as much as possible. With a lot of components, it can be sometimes a little slow calculation and simulation. So if you have your own custom tool, please try to be serious. Okay, now we can see toolpath, and very nice. What I didn't mention is that in the link we have one more possibility. If I will imagine that I will do this first angle, this first thread, and after that the second thread, but I don't want to return back, we have options for this thread. The retract level will be the keep tool down. So it means that when we will finish the first one, we will keep tool down on Z minus, I think it's 20, and from those minus 20 we will start another thread, which is this one. Okay, currently I have only one, so it will not show, but this is something what you should know as well. Okay, and again we have here the possibility to use index rotation angle. So if you need to rotate by some angle or different part of the cutter, it's easy. What I just remember that I didn't show at the beginning is start angle. If you have some specific place where on your part where needs to be or where needs to start your thread, it's very easy to rotate it by this start angle. So by, for example, 135, and we can see that, exactly, I put it to the X plus. It works also for both, I mean for multiple start or for one start, for both of them. Okay, so that's, I believe, pretty much everything from my side. What if I will a little bit summarize it? What would we show together? We showed custom thread we showed customized profile. I show you how to create your own tool from the manufacturer side, how to create your cutting point for the inserts. For a little bit sneak peek for the upcoming versions, I can tell you that now we are currently working on the variable pitch. Exactly like it's in the SolidWorks. So it means that if you have a pitch which is consists of different diameters and different pitch, it will be possible to support. Now we are intensively working also on the selection of your cutter side. So like I showed to you X plus, X minus, Y plus and Y minus. It will be completely new option. And also on all simulations which will be much faster. So that was some summarized and some sneak peek for the new versions. And I believe we
have two questions. Actually, we have three questions. The first question is, can you please repeat what the cutting length in ToolKit for thread whirling insert represents?
Sorry, one more time. I didn't understand the question.
Can you please repeat what the cutting length in the ToolKit for thread whirling insert represents?
You mean this link when I break the link over here?
No, what the cutting length in the ToolKit for thread whirling?
Ah, you mean this one?
Mm-hmm.
Ah, okay. So I understand. Okay. Thread cutting. This represents how deep will be your cutter. Okay. I was in order to do it completely right, you should measure your top and the bottom of your insert and put the value there. So in my case, it's like something 4.558 if I remember correctly, but I didn't remember correctly, so I put hard-coded 20. So it means that from this place, the 20 millimeters, everything what will touch the part will be actually done as cutter. Okay, so yes, you're right. In order to have it correctly, I should measure my insert. Let's try to measure exactly like it is. It's 3.690. Okay, so here it should be 3.690. I did it by fast way, so I put 20 like that. So I hope it's clear now.
Okay. The next one was thread cutting the CL parameter. What is it?
It's the same story what I just told. It's actually from the top of the insert to the end of the insert. It should be the length of the insert.
Okay. And the last one we have, if we create a helix sketch on SolidWorks, can we use it for use on thread whirling?
Currently not. You can use only profile which is in XZ plane. Okay, but we are trying to think about these options for the future. That when you will have some, yes, when you will have some, for example, this one. When you will have, for example, this one, this helix, to use it in the operation, in the job itself. But this one will be for the future, okay? Currently, we can do it only in a ZX plane.
Okay. And one final question, which SolidCAM version is being used right now?
Right now it's being used SolidCAM 2023 SP3 hotfix 2, if I remember correctly. But it's same in all branches, so 23, 24, and even 25 if it will comes early. So on all versions, thread whirling it's same currently.
Excellent. Well, thank you, Stanislav. Thank you, everyone, for joining our webinar. We hope you enjoyed the presentation. And if you have any questions, please reach out to us and we'll get back to you. Thank you all very much.
Thank you. Have a nice day. Bye.